So we've covered the basics of object-oriented programming, and we could probably easily go on and on for video after video after video to look at all sorts of different scenarios and complications and different ways of storing. And we will get to some of that as we start to look at lists and arrays, multiple objects. But there's a few kind of key pieces that I think I want to kind of mention. I originally intended this to be like 3 or 4 videos, but I think I'm going to give you a survey of a couple added features of object-oriented programming that, even if we don't get into in depth here, will get you kind of like thinking and know some terminology. You can kind of do your own Google searching or look at examples and complain to me to make more videos at some point too. So the first thing that I want to mention is just the fact that we spent a lot of time kind of understanding the idea that a class is a template for making an object, and the class has data in it and functionality in it. Some variables and some functions. A key piece of information I think to realize and think about is that this data doesn't just have to be a float or an int or just a bunch of simple numbers. It could be other objects. And I think there are a lot of scenarios where it makes sense to program this way. For example, let's say you were making a body object. So we had a class called body, and the body conceptually has a head and a torso and an arm and some legs and a hand, right? My terrible drawing skills aside, you can see that this body is made up of multiple pieces. And we might start having things like, head X, head Y, head size, arm up. But what if we thought about this, that actually what a body is it is a head, it is an arm, which is like the right arm, and it is another arm object, which is the left arm, right? And so what does this mean? I need to write a class. That is the head class. I need to write an arm class. So this idea of a hierarchy, that the data of an object could actually be other objects. And later when we look at lists of objects, what if I have a particle system with 1,000 particles? I might have an object that has a list of 1,000 other objects in it. So this is all of this idea of nesting, of creating some type of organizational hierarchy, is something you should be thinking about as you start to build out larger and larger programs. Okay, so I just wanted to briefly mention that. Another thing that I think is worth kind of briefly mentioning, even though you kind of don't really need it that much, but you might see it in some examples, is you can actually write more than one constructor. So I just want to come over here. I have this very simple example where I just have a particle class. Particle class is just an x, a y, and a size. And here we have 2 particle objects. Notice the particle constructor receives 3 arguments, a temporary x, a temporary y, a temporary r, to fill those parameters of this object. So what if I wanted to do this and say, okay, well, if I specify the 3 arguments, then I want those arguments to be the pieces of data for that particle object. But what if I don't specify any arguments? Then I just want you to make a random particle. Well, this is actually quite allowed and common. I could write a second constructor that takes no arguments where something different happens to those variables. So this is what's known as overloading. I've overloaded the constructor, meaning I made 2 different versions of it. One that requires 3 arguments, one that requires no arguments. I could make a version that requires 2 arguments, or one that requires 4 arguments. And this is actually quite common. And in fact, this is not just limited to the constructor. After all, in processing, you can say fill and give it an RGB, or you can say fill and give it just a single grayscale value. You could give it 4 arguments for an RGB and alpha. And this is something that the designers of processing have put into the API. Many different versions of the same function that expect different numbers of arguments. And this might be something that you think about as you start to build out programs yourself. So if I come back to this, I'm going to get rid of this third particle. I could say, hey, let me make the second particle just be random. As you can see, whoops. When I run it, why is it always in the top left? Something is wrong here. X is random width, Y is random height. I don't see why that should happen for P2. I'm after size. I'm sorry, I forgot that I had this extra piece of code in it. That's putting it where the mouse is. Sorry. So you can see that every time I run this, that second particle is somewhere else. And now if I go back to what it was before, something like this. You can see now I'm specifying it's always going to be over there. So this is something, this idea of overloading is something that you can do. Okay, so there's one last piece here that I want to look at. And I'm going to just sort of scratch the surface of this by looking at a kind of simplified scenario. But this way of thinking, I think, will apply to lots of things that you might, whoever you are, might try to do at some point. So let's think back to this processing sketch we have where we have these two objects on the screen. How do we get these objects to communicate with each other? How do we know when they're overlapping or not overlapping? How do we know, how do they know their distance apart? What if we want something to happen when they get close versus when they get far? So this idea of having two objects communicate with each other, this is a kind of key concept that involves some techniques that are a little bit beyond just the basics of object-oriented programming. So let's look at this for a second. There's a few different elements here. One, so let's just take for a second, how do we know if two circles are overlapping or not? So each circle has a radius, R1. This circle also has a radius, R2. We can clearly see that these circles are not overlapping. And I can clearly see that these two circles are overlapping. The key piece of information we need to know whether they're overlapping is the distance between them. The distance between them. And the way we can determine if they're overlapping is if the distance is greater than the sum of the two radii, this being one radius, this being another. Clearly, if you add these two together, the actual distance is longer. However, if we look at this radius plus this radius, the distance is shorter than the sum of those two radii. So this is one way that we could determine if two shapes on the screen are overlapping. So let's come back to this program and let's sort of see if we can figure that out here. So I could say, for example, what is the distance between P1x and P1y and P2x and P2y? And if that distance is less than the sum of their radii, then let's draw a green background. So if we run this, no green background. And if I were to put them as overlapping, yes, a green background. So let's do something where I can put this piece of code back in here where I can just kind of move this one's location. And as soon as I come over here, we can see we get this green background. And let's make the stroke weight a bit bigger. Okay, so just so we can see here. Okay, so you can see we get when they're overlapping, when not. But while I've done this, what I haven't really done is I don't like the way that I did this. I just kind of had some gobbledygook code out here that's like checking these values together. But really, what I want to say is the following. If P1 overlaps P2, then draw a green background. If P1 dot overlaps P2, then draw a background. Okay, so how do I make this happen? How do I write code like this? This is so nice, actually. This is what's going on here. I know we have, I have a display function. I can display P1. I can display P2. I'm now saying if P1 dot overlaps P2, then do something. So what's going on here? Just like there's a display function, I now need to write a function called overlaps. And what is the argument? What are the arguments to this function? Okay, so let's start doing this. What the reason why I'm kind of like lost my train of thought here, but the reason why this is useful is this way of thinking in terms of object orientation and calling a function on an object and passing another object into that function. This is now unlocking the key to what code I actually need to write. I need to write a function as part of the particle class called overlaps. So I can actually go ahead and do that. But I'm missing some stuff, right? When I say overlaps, I'm passing in another object. So now what I need to do is pass in some other object. I'm just going to call it other. So the overlaps function takes an argument which is some other object. This is a little bit strange conceptually because we're in the particle class, and yet I have a function which receives another particle. What you have to remember is the idea here is you can call the overlaps function on this particle in reference to another particle. You could actually check if a particle overlaps itself, but that would be kind of conceptually flawed. The other thing that I think is key here is, notice this function is inside an if statement. So p.overlaps p2 has to evaluate to true or false. Right? It either does or it doesn't, which means that this function needs to return a Boolean value. So the function overlaps, receives another particle, and answers the question, am I overlapping that other particle? Yes or no? Return true or false. Just for right now, I could just say, let's not bother to implement this. Let's just write return true in there. And I'm going to take this out of here and get rid of this stuff we worked out before. And now I'm going to run this. And of course, it's always green because I'm always returning true. Now I could go back to this function, and I could return false. And now it's never going to be green. But this isn't what I want to do, obviously. In here, now here is the place where I want to write that code where the object that I am right now, the particle object, communicates with the other particle object. So how do we do that? I want the distance between what? Okay, I'm a particle object. I'm in the particle class. I want my distance between my location, x comma y. And then I want the distance between my location and some other particle that's coming in as in the argument, its location, other.x, other.y. And then if that distance is less than this my radius plus the other radius, return true. Otherwise, return false. So this is now a function inside of an object which receives another object as its argument so that the two objects can talk to each other. They can compare their locations, they can compare their size, and if we run this, now you can see it's working again. The reason why this is so useful, and it's not really emphasized here, is that I could now check, if I have 5 different particles, I could just check if P2 overlaps P5, or if P3 overlaps P1, or if P4 overlaps P2. So I have a generic function that checks if one object overlaps another object. Now, I realize in making this quick example, this is a little bit tricky, and it might actually have been a little bit simpler if I had, particle objects and bubble objects, and the particles check if they're overlapping the bubbles, because then you wouldn't have this thing where you have a single object checking another object of the same type, which can be a little tricky. But this is kind of a way of thinking that you, I think, want to get used to. So as an exercise, I might give you the following exercise. Take this idea, re-implement this, basically this exact same code, and instead of having 2 particles, have 3. And can you make something different happen when these 2 overlap versus when these other 2 overlap? And I think that would be kind of a good way to start. So how could you have maybe try 4 particles or 5 particles and have different things happen with different combinations of overlapping, and see how that goes for you. You might also want to file this in the back of your mind that later when we get to looking at arrays and lists of objects, how would you have every particle checking if it's overlapping every other particle, which is kind of a tricky problem. Okay, hopefully this video did some good, and I'm going to hit stop now.